thank you everyone for being here today. We're going to start with a presentation by Louis Pujol, who already talked briefly 3 weeks ago. So as you know now, Louis is an engineer in our team HeKA, and we work together on this Scikit Shapes project that should be released at first versions at some point in the summer. And so as we started to work on this, we investigated, okay, currently as of 2023, what software tools are available to make a small graphical user interface for 3D. And basically, we were blown away by recent advances in the field. And so we wanted to present them to you. So let's start.
Okay, so thank you for the introduction. So first of all, I want to say that all I will present to you today is on GitHub. So you have here the link for the repository. You can find all the material, and I think some things have to be updated in the next days. So you can check here for changes in the next days. And so for my presentation of today, so my goal is to give you information about what is possible to do for 3D visualization in Python by presenting you mainly two tools, and you will understand why I present two tools and not just one, which are PyVista and Vedo. So my presentation can be separated in two parts. First of all, I will give you an overview of what is the ecosystem in which these tools are. And then I will show you with some notebooks, some code and how you can use them. So I will not go into much detail about the code. So all the notebooks are online. If you are really interested in apply these tools, you can check the notebooks and see the code by yourself. So first, the ecosystem. So in this image, I just do a small recap of what is going on when you want to display some things, some 3D thing on your computer. So at the very low level, you have here so I put all in the same box, but of course there are a lot of things to say about it. Your hardware, your operating system, and your devices. So here you have a GPU, here you have a computer, here you have your smartphone, switch if you want. Why not? Here the logo of Linux. So in this presentation, I will, of course, not talk about how to program some GPU, but you may keep in mind that at some point, you need to be able to communicate with these tools to display something. And the tool that talk with the hardware is a graphical API. So a graphical API is mostly C++ library that allows you to communicate with the hardware, and it's very low-level programming. For example, when you use OpenGL, you can say, okay, plot a point there, and you have a lot of graphical things. So OpenGL is an old project, so starting in the beginning of the 90s. If you want to know more about this, I recommend you to have a look at this blog. So you can learn things about graphical API and that's it. So OpenGL is something widely used in a lot of domain. So for example, there are some projects that are using OpenGL. So you have video games with here Doom. You have some. Sorry?
What is a video game?
I think I will present video games in the next next presentation. So it's Doom, Autodesk Maya, and SketchUp are tools for here building some animation, I think, some 3D characters, and here some architecture. And QtMol, which is a tool to visualize molecules. So all of the tools use OpenGL as a graphical API. So this is a very important tool.
Louis, just a few words on the other graphic API, like Webcam or what?
Okay.
Do you know something?
I do not know a lot, but I can recommend you to go in this blog because he explained a little how they work, and for example, he look at some video games and explain why things are rendered this way or not. So yeah, I don't really know how to use them. I would just want to mention them, and
Yeah.
I can link this blog to
My question, I just know DirectX on OpenGL, but
I talk about OpenGL mostly because I will present VTK, and VTK is based on OpenGL. This is why this is just not a choice. I don't say this is the best graphical API or something like that. And so the graphical API is a low-level tool to be able to communicate with the hardware and display things on the screen. And build on top of that, you have other programming API, and the one which will interest us today is VTK. So VTK stands for Visualization Toolkit. It's mainly a C++ library, including data structures for some kind of data like grid, images, or meshes, some operation and filters on this data, some rendering functionalities, so based on OpenGL, and tools for interaction with data. So a typical workflow in VTK is that you have a team of programmers that know how to write code in C++ and VTK, and they write some standalone application. So here is an example of a bit of the ParaView code. So if you can see, it's not very easy to read if you do not know VTK, but at the end you end up with applications like that. So this is ParaView, which is a tool for visualizing scientific data. And you can use a graphical user interface. Even if you don't program, you can so you can use VTK with a graphical interface. But in this workflow, you have on one side the programmers which design the application, and the user, we do not program at all. It just uses the application by clicking here on the screen. And then on top of VTK, you have some Python libraries, and it will be the subject of the rest of my presentation, PyVista and Vedo. So both are based on VTK. So when you work in Python and you use PyVista and or Vedo, you are in fact calling some VTK code under the hood. And the interest of having such tools is that you can use VTK. So it's a way to use VTK in Python, which is a scripting language. So you can write small scripts. So here with 3 lines of code, you can open this window on your screen and visualize a mesh. Okay, so it's kind of intermediate level of complexity that you do not have just with the C++ interface of VTK. And of course, when you run this code, under the hood, you have all the pipeline from PyVista or Vedo to the C++ engine VTK, to the graphical API OpenGL, to your hardware, your screen, where you show. But in the presentation, we will focus just here at the level of Python, and I will show you how you can use and what you can do with both tools here. Okay, do you have questions so far? It's clear? Okay. So now I want to show you some functionalities of...
Maybe zoom a little bit.
Okay, yes. Je vais me mettre là comme ça. So now I will show you a series of notebooks. So I will execute the code to give you an idea of what is possible to do with PyVista and Vedo. So for the first, I will show you some, I think, quite natural pipeline you want to apply with geometric data, which is loading some files, manipulate them, apply some transformation, maybe display them again with the transformation, and at the end save your transformed data. And I will show you in parallel with PyVista and with Vedo, because these operations you can do with one or the other libraries. Under the hood, they both call some VTK code. So if you are using one or the other, you are in reality doing the same thing, but they're presenting differently. So maybe depending on your flavor, you want to use more one on the other. I want to show you that some things are possible with both. So this notebook, so it's just to show you briefly what you can do. So first with PyVista, you can read data. So here I have three files. So one image in PNG format, one ANI 3D scan, and one VTK file, which is a mesh. So I can load them with PyVista by calling the read function. So it will automatically detect the kind of object I want to load. And then I can print the type of each object, and these objects are identified by PyVista as grid for the images, 2D and 3D, and poly data for polygonal data for the mesh. So these are the internal type of object of PyVista. And then you can plot them. So here on the same plot, I have three subplots. So you have the image, you have the volume, and here you have the mesh. Okay? So
did you want to install something specific?
No, it's when you open PyVista, the fact that you can move, it's internal to PyVista. So when you open a PyVista plot, this is something interactive. I have nothing to say to PyVista.
Is it possible to embed this in HTML?
In HTML, I think yes. I do not read this. You can, for example, embed these things in Qt. I know. I think there are possibilities to embed them in HTML code.
Yes, so maybe your point is that Kitware, they are clearly working on this at the moment. It's called VTK.js, VTK JavaScript. So, but I don't know how much of the VTK stack is currently supported.
Okay.
But I'm pretty sure that in 2 years it's going to be.
Okay, 2 years.
But I think it's possible, yes, with PyVista and Vedo. I'm not sure. I think on the doc you have some things.
Just import functions, getting you something which is usable by a navigation or like.
I didn't try, so I don't know if it's the case for the moment. Okay, so this was with PyVista. With Vedo, you can do exactly the same thing. So in Vedo,
you can zoom in and zoom out.
yes. So basically, you have some some functionality that you can play with the camera.
Can you
I
link
don't
the
know.
cameras of the three?
Can I? Sorry.
Yes.
In PyVista, I'm not sure, but in Vedo, yes, you can for sure. You have an option share cam for the three plots. I'm not sure in PyVista, but maybe. So in Vedo, it's the same spirit. So you can load some files, and here you have the type of the data. So here the types are different because it's the types defined in Vedo. And yes, here in Vedo you have the sharecam attribute. And if you I will put true. And there is a. Yes, it's because I shared the. Okay, so here you have the.
So you are inside. You are inside. It's just a Jupyter notebook. You are inside. What navigator standard?
So here I'm inside the Jupyter notebook. So in PyVista, as you saw, you can plot the window inside the notebook. But if you execute code with PyVista outside the notebook, it will pop a window like this. And in Vedo, you can, from the Jupyter notebook, open a window. And so, yes, so in Vedo you have different default option for rendering. So it's not exactly the same color, for example, for the mesh, not the same representation for the volume, but you can also visualize this data. So then you are able to load the data and to plot them into interactive representation. Now you can apply some filters. So when I talk about filters, I will just show example of two filters. There are filters that are defined in VTK. So one is triangulate and the other is decimate. And so here I load a mesh which is composed by rectangles. I apply triangulate to obtain a triangular mesh from this rectangular mesh. And then decimate is a function that allows to reduce the number of triangles, to lower the resolution of the mesh. So there are filters defined in VTK, and PyVista and Vedo offers you the possibility to apply them on the objects on PyVista. So you have an interface for using the VTK filters in PyVista or Vedo. So if I execute this, so this is the original mesh. This is a mesh after triangulation. And this is a mesh after decimation. So this one, just to show you that I can do exactly the same with Vedo. Original mesh, triangulate mesh, and decimated mesh.
The same function, so it's the same meshes.
Yes, it's exactly the same. So the syntax is a bit different because using PyVista and Vedo, but under the hood, if you are looking at the source code, they both call the VTK function. So yes, you are doing exactly the same thing. Okay, so I know that you can connect Mesh IO with. I know that in Vedo you have an example of a script that connecting Mesh IO with a Vedo object, and I think it's possible also with PyVista. Once you are able to go back to the VTK object, because all of this object have VTK object inside, so it's always possible to. So I know that TreeMesh, Mesh IO can be connected with them, but I do not know a lot about Mesh IO, so I can't give exactly that.
The Python package or and meshes like somebody wants to deal with meshing.
But I know, yes, Vedo has, I think, explicit converter to Mesh IO format. It could be possible also from PyVista to Mesh IO. I don't know if it's hard-coded in PyVista, but yes, I think at some point you can make different tools interact. So here it was examples of filters that I defined on VTK and that you can apply to the mesh. And on this notebook, I want to show you that you are not limited to the filters that VTK provides, but you can also applying any transformation you want. And by doing so, I will show you an example here. So I can show you directly the result. So on the left in red, it's my original mesh. And on the left, I applied translation. And on the right, I take the original mesh and I remove two triangles. See here, there are holes. And so I can do this just by first loading the mesh. And then I can apply some operation with arithmetic with NumPy arrays. So here it's very simple. I take the points of my of the original mesh and I add a translation. Okay, so of course you can imagine what whatever transformation you want. So you can build your kind of your own transformation on the data. So you can also change the topology. So here it's in this example, I want to remove some triangles. So to do so, you need to have an idea of how the triangles are stored by the different mesh objects. And here in PyVista, the way they store information about triangles is by put all the information about all the triangles in just one list. And the list is organized as follows. So if you read the first element of the list is the number of elements of the first face. And in the case of a triangular mesh, it will be 3. And after, the next 3 elements will correspond to the vertices that compose these triangles. And this representation allows to have, for example, triangles and rectangular cells. Okay.
When you say vertices, you mean
indices? No, I mean vertices, the indices of the point. Yes. So it's integers, just integer in this list. So this is a way PyVista represents faces, and since you know that, you can apply what you want. So here with this line, I remove the 4 first elements and the 4 last elements of this list. So it corresponds to removing the first and the last triangle. And just by changing the attribute faces, I obtain here the same mesh, but with two triangles removed.
So you obtain a copy of the mesh, the data?
No. So here, yes. So I copy the original mesh because I want to keep it in memory to display it. But when I change attribute faces and point, it's in place.
It's just rendering time, so it's not change.
So it will just link the attribute face here with a new array, but it will not change the other attributes of. So I think, but I'm not sure.
Sometimes you can just change the way you are rendering the mesh on the data. So you're just saying to OpenGL, okay, when you just eliminate this pixel instead of this, but the data is the same.
Okay.
Graphical computer scientist likes a lot this because you pay no copies.
Okay, I'm not aware of this kind of thing. So here, my example of translation is more to say, okay, maybe you maybe you want to apply some more complex algorithm to the point, so you can basically work with them as NumPy arrays. But maybe there are some smarter way to do just translation. But
it's like just to know when there is a memory.
Okay.
Well, you just can choose if you pass the stuff by reference or it could be just say.
I think here is really just to change the pointer of the attribute points. So the rest of the object mesh in PyVista do not change.
Yeah, but there should be a data array storing
okay.
too. So you need twice the memory.
So I think here it's managed by NumPy. I'm not sure because it's an operation between NumPy arrays. So maybe.
No, so I think definitely in the picture here, because you are rendering the 2 translated copies, I think in memory you have 2 NumPy arrays, one for the original and one for the
yes.
There is not a super clever way. Sorry, I don't think it's something that can.
Yes, here I explicitly copy at first the mesh. I didn't try to optimize this.
Is there a way to?
I don't think it's that large.
I don't think no, it's not no. And okay, so it was this example with PyVista. So you can do it also with Vedo. So I do not go into details of the code. I think if you're interested really in how things are encoded, you can just see the notebook and read here the comment, but I think it will be too long to say everything. So, okay, you obtain exactly the same output with Vedo. So here again, you can choose to use one or the other tool. And so now, I had also another one, but here I just had the time to do it with PyVista. It's another example of here I do not apply a transformation on a mesh, but on a grid, so on an image. So here I just apply, where is my operation? Yes. I just invert the color of the image. So as before, you can apply whatever transformation you want. And I think there is something like an invert function already in PyVista. It was just to show you that you can manipulate the image, the pixel of the image as you want. You are not limited to the functionalities of PyVista that are directly available.
So what you have here is just an image, or you have a mesh?
Here I have the image, so I load
the data structure is just...
Okay, the data structure, so it's on PyVista, when you have an image, you have a grid. I think I can show like this. So when you have an image in PyVista, so it's the way PyVista encode information, you have a grid, so which is just the information. So here it's a uniform grid, so you have the number of cells and the bounds of the grid. And attached to this grid, you have a data array. And this data array corresponds to the information about the pixels. So here, what I do for modifying the pixel, I apply here get array. So I extract the data array from the grid and I apply my transformation.
Okay, so
it's a grid.
So you have geometrical supports?
Yes. And
plus
attached, you have a data array on top of the grid. And I think it's like that because after you have the possibility to have multiple data arrays on the same grid. And so you have independence between the grid and the data you...
Yes. And so in memory, it's still a genuine grid. So it's not a soup of triangles. Or could assume that they are making a very inefficient conversion, but there is built-in support for volumes.
So, okay, so a quick summary of what I presented so far. So both PyVista and Vedo can be used for following this pipeline. So you can load the data, you can display, apply transformation, so VTK filters or your own transformation, and you can display the changes. And I didn't show it to you, but you can save mostly using the .save method. So you can save your objects as, for example, .vtk if it's a mesh or .png if it's an image. You have some differences between both. So here I did it a little bit quickly, so I didn't highlight all the differences on the code between PyVista and Vedo. I insist on the fact that you can do the same thing. But if you read more carefully the code, you will see some differences. And okay, it's a very personal opinion, but I think if you are really interested in applying this pipeline and have some basic plotting, so just plotting meshes as I did before, for me, PyVista is a bit better than Vedo. And I think one major reason is that in PyVista, you have a logical separation between what is a data structure on one hand and what is what they call an actor, which is a rendered object. Okay, so you have the mesh, you can manipulate the point and the triangles. Then you put the mesh in a plotter, and you have the mesh and you have an actor, which is a mesh in the plotter. And for example, if you want to change the color, it's at the level of the actor that you change the color. In Vedo, the logic is different. A Vedo mesh is a mix of information about data structure and visualization. So you can change the color after decimate. So you do not have this separation. And I think if you really want to apply some pipeline like this, where in some part you want to do some transformation, some geometrical transformation, and other part you want to do some display, PyVista offers you maybe a more clear interface, but it's a personal view on the subject, and I recommend you to have a look at both. And under the hood, they use the same tool, which is VTK. So you can use both there. And good news, so as they both use VTK, good news is that you can go from one to each other. So here in this cell, I load a mesh in PyVista and I convert it to Vedo. So, oops, no, this is not what I wanted to write. I hope it will work. So you load the mesh with PyVista, and to convert it to Vedo, you just apply vedo.mesh and you pass as input your PyVista object, and it will do the conversion. You can do it in the other way. So here you have to translate at first your Vedo mesh into polydata by calling extracting the polydata from the Vedo mesh and calling wrap function from PyVista. But you can transfer your object from PyVista to Vedo. So if at some point in one of your programs you want to use a functionality in PyVista which is not in Vedo, or the opposite, you can do conversions with this small piece of code. So, okay, so it was the first part of the demonstration of Vedo and PyVista. So, if you have questions about what I have presented to you so far, I will move into a bit different topic for the two of the notebooks. So, if you have questions about this, maybe you can ask them now. No, it's okay.
Maybe.
Yes.
Yeah, maybe about, so you said you can load only VTK objects? So usually we have many different file formats.
Yes, so I did not talk a lot about it, but this is something very powerful. I don't know where is the link, but with, yes, you have a lot of file formats you can. So this is a list of the reader you have when you call PyVista read. So, okay, there is a long list of tools. So you have files from VTK, you have already all the classical images file, you have other files from different subjects. So you can have a look here at the list. For Vedo, I do not find a similar list, but I tried vedo.load and I was able to load different file formats. So yeah, basically it's one of the strengths of PyVista and maybe Vedo, but I'm not sure of the one strength is that you can really open a lot of file format.
Yes, and so maybe, to the new students, it's really impressive, right? Because just 4 or 5 years ago, for every different file format, you need to install a strange, poorly maintained C++ Python library. So it was really a mess, whereas this, you just make pip install PyVista and basically that's it. So that's super impressive in terms of reducing our whole workload for people who want to do just modeling.
and I think this will be in scikit-shape. We will rely on the PyVista.read to as an entry point for whatever kind of data you want to proceed. Yes.
And we have another question, so I just try now and it doesn't work. So.
You should not do that.
So maybe you put a guide at the README file here.
Yeah, so
install PyVista all train. But it doesn't work with this whole thing. Is it normal? Or?
I don't know.
Because you
I think so. The old train is for be able to render things on Jupyter Notebook.
Mm-hmm.
So you can Google PyVista Jupyter Notebook and you will. So the README I just wrote it in 5 minutes, so it's not very. Maybe I will improve it, but you can check the PyVista doc, PyVista Notebook, Jupyter Notebook. Maybe the.
Doesn't it depend on like VTK or OpenGL installations on the computer?
Maybe I do not remember because I think at some point I had to solve the issue, but I do not remember exactly if I did not do something else.
So you think that Kipware, they package VTK via pip, so it's much easier to install than it was previously. So I think you can make it work without compiling anything, which is already.
this whole thing doesn't work at all. Now, when you say PyVista install PyVista, pip install PyVista all, it says all is a bad pattern.
Okay, so maybe remove all and just pip install PyVista.
No, this works, but then there is a problem with the Jupyter Notebook. So it's needed.
I think I used. Because I remember at the beginning I can't do it. Yes, I'm not sure I can debug you in 1 minute,
okay,
but sorry for that. But I'll try to improve the README of the. Okay, thanks for the remark. But I think if you just pip install PyVista, you can copy and paste the bit of code in .py and execute Python, and it's generally a more easy way to use them. Okay, so now I presented to you this pipeline, and I showed you that you can do it with both Vedo and PyVista. And now I want to show you something I think is really more related to Vedo, is the ability to build some really impressive applications and really interactive things. So to give you a first overview, I want to show you the doc of Vedo. So when you go in the Vedo website, you see a gallery of example. And okay, so I think the first remark you can say is that everything looks beautiful here. It seems that you can do awesome stuff with Vedo. And in fact, you can do awesome stuff with Vedo. So I will not run all the example, but I suggest you to go on the web page, on the Vedo web page, and see what is possible to do. So in this notebook, I will show you something which are the Vedo applications. So in Vedo, you have the examples, which are the things I just show you. So you can copy and paste the code of one of the example and try to change it to suit what you want to do. You can also use a module in the library Vedo, which is called applications. So here it's an example of a first application, which is a browser. So I load a mesh, which is Beethoven, which is from the data repository from Vedo examples. And then I create a list where I decimate different times this mesh. And after I call application with, as an argument, the list of the decimate meshes. And if I execute this, I have here a slider, and I can go through the examples I had in the list. So this is something maybe you want to, you can use for different application, you have a series of objects, and you want to show them on the same screen. So with Vedo, you have just to do that, and it's okay. So you have other cool application. This is something maybe you want to consider. This is a 3D slicer, so okay, and it's already code in Vedo, so with no effort, you can load your own data and interact with it. Another one is,
Question. So that 3D slicer, does it have to be an image, or could it be a mesh that you were then slicing and seeing later?
I do not try. I use with my volume because I thought it was natural data to feed into the slicer, but I don't know if you put a mesh here as an input, if it works.
Yeah, so maybe not out of the box, but there is a tutorial, basically just one function, you have your mesh and you say turn it into a volume, and then you put the volume in there. And all those conversions are explained really nature.
And so another built-in application in Vedo, it's, so I don't know if you can see it, maybe not, but here you have some instructions. So you can click on the mesh to add points. And so here, if I click, it add a line with, I think it's computed with splines to compute a curve on the mesh. With a right click, I can remove the last point. Why not? And when I go back to my notebook, so during the execution, I had some print of what I have done. So which point I have add to the mesh, and at the end, I am able to. So I have a copy of the points I have selected, and then I can use them in further in the rest of my program. So I can, with this kind of interaction, so extract some information with for example, clicking, and then take this information and use it in another part of my program. And so this was the built-in Vedo application. So in one line, you can have a slicer 3D or the things that are hard-coded in Vedo. And what is also interesting is that based on that, you can create your own Vedo applications. So in this notebook, I will show you an example of two applications I have coded. Based on the last one I saw you with the mesh, when you can click and it creates a curve. So the applications are not defined in the notebook itself, but in the folder applications. So you have landmarks and control points. I will show you the applications, and I will show you what is possible to do with not a lot of effort. So here, my application take as an input a mesh. It shows the mesh, and with E, I can add a point on the surface. So if my cursor is somewhere on the surface and I press E, I add a point. I can also delete last point. And with Z, I can put a point, but not anywhere on the surface. It will place the point on the closer vertex. And when I close my application, I can call app.points, and I recover the 3D coordinates of the points I've selected. So it could be useful, for example, here for select landmarks on a mesh. And the second application is that, so you can add a grid. Can add a grid to the mesh. So as an input of my application, I have the mesh and a parameter to say here I want 4 points in each direction on my grid. So the granularity of the grid. And here with Z, you can select points on the grid. And when you click, again, you can extract the point you have selected, and then you can use them in further computations. So
this is something you have developed. This is included.
So no, I created both applications based on the. So I can show you the code just to give you an idea of how long it is. For example, for landmarks. So this is, yes, 85 lines of code. And it is based on an application already existing in Vedo.
Yeah, because you need to do some kind of projection. Basically, in the first application, you click and you have to say that this is
okay.
So mesh, so should be some kind of computational projection.
So for this, so here you have some already is here, so you don't have to do so. And this is interesting because in both example you have two different way of dealing with this kind of things. So in the first application, so the landmark, you have directly in Vedo a function which, so when I press, so when the event press E, for example, is so when I do the key press, I can do a if statement. So if my cursor is on the mesh, put a point at the point on the mesh that is close to the cursor, and it understands that is close in the sense of 3D. So it's a VTK event. He understands that I am on the mesh. So someone in VTK coded for me. So I don't know how it works, but I
kind of headache. You have to do it.
And on the second application, because it was hard to, if I use the same code as before, it was hard because every time I was limited to select point on the first face of the face of the grid, which is at the front of the screen. So it's hard. But you also have the option to say, so here when I press Z, what I do is that I take here the screen coordinate of the point of the grid. So it's integers triplet of pixel. And I also have the screen position of my cursor, and I just do nearest neighbor search. I can, so it's built in VTK. You have both event in kind of where I am in the 3D world of meshes, etc., and where I am on the screen. And it's not very hard after to write what you want to this code.
Like in this is not, I think they have not a strong, I don't know if this is the view, but they have the impression, I think the visual impression is strange.
It's hard, I think, with grid to, yes.
That's hard to, but
If things in front of you makes it look.
yeah, the grid should be, when the Ibella is embedded inside.
The grid should be, in terms of visualization, the object should hide a little bit the grid in order to better visualize.
Ah, yes, yes. I keep the opacity, yes, the opacity of the grid to 1 and just, but yeah, maybe there are better way to visualize things. But you can change it very easily.
It does, you can see if a point is behind or in front.
Oh, when you get.
Maybe I think when you move a little.
Yeah,
Otherwise, the question about this application thing.
Yes.
What's the difference between what you coded and the fact to just code a function independent of, like for example, you show the code that you have, which is so it's a class that inherits from
for a plotter. Yes.
What's the interest of inheriting from video plotters? Vedo. What does it give you? What's the difference between this and just coding your own function that does what you?
No, you can. No, definitely you can just code your function. Here the structure is just that I copy paste from the example of Vedo.
But there must be something.
But I think the thing I saw here maybe it's related to its close of what you do when maybe you define some Qt window. It's something like this. I found the structure useful. You define your. It's interesting, yes, to have a class because you want to define your callbacks. So here I have just one callback when there is a key press, but I can have different callbacks if I add some sliders, button, etc. So I think it's not a bad idea to have a class because of that. Then you can inside your class define different things, but it's not mandatory. And even this is something I think Vedo is very good because you have all these possibilities with visualization. In other hand, it's kind of sometimes experimental. So if you go from one application to other, you don't have same syntax, etc. So it's not very. You don't have rules about how you have to design application. And I was just inspired by what was done in previous code, but I don't know if that's standard.
Yeah, I don't know if that's how you want to conclude, but I think when you go on the websites of those libraries and when you start using them, you can you clearly have a different feeling, because both of them rely on the same internal engine. As we show, they are fully compatible with each other, but you can really see that PyVista, it really feels like Matplotlib in 3D. Like it feels like a data science library on the documentation, etc. Whereas Vedo, you can feel that it's more a graphics library. It's designed by someone who likes to add widgets, etc. And so
Yes.
you just feel that for different needs, you want to have a different set of features, and that's basically what they provide.
Yeah, definitely. So yeah, it was so for the 3 or 4 first notebook where I showed something maybe more data science based pipeline. I think PyVista is a better competitor. And then for what is visualization and interaction, Vedo is, I think, better. But they both rely on VTK. They both, under the hood, use exactly the same engines. So it's good, I think, to have an idea of what are both of them. But when you choose to use one of them, you are not far away from the other. So these tools are interconnected. So yes, this was this is a message I want to pass to you. And yes, after, so I provide you the notebooks, so you can here you have some references, so mainly references to the documentation of both libraries. If you look more closely at the code, you sometimes have more details about implementation. So if you are interested in adapting this code to your data or want to show, for example, more filters, etc., you can check it. And so, okay, I show you all the things I wanted to show. I planned to add 2 other notebooks, so for the moment they are empty. But I will try to put things on them on the next days. So the first will be maybe low-level information about the relation of VTK, Vedo, and PyVista, and how you can compile your own version on VTK on your computer, and so more on this interaction between those tools. And another notebook I plan to do is integration with Qt. So Qt is a tool to do some graphical windows with buttons, for example, options to choose files, things like that. And okay, maybe in this one, but for the moment I didn't try it. I should add some things like adding a plotter on a web page, but I do not know if it's easy or hard for the moment. So I can tell you I can check it. So okay, I'm finished the presentation. If you have some question, you can ask me.
Thanks a lot first. And so who is supporting this library that is developed? The fact is that
I can go back to the ecosystem, and
in 1 week, Jean will come saying, PyVista, okay.
It's over.
It's so 223. No, just okay.
I think it's a really good question, and that's exactly, when we are discussing this paradigm shift of, 5 years ago, we are developing monolithic C++ library. It was very hard to share ideas. And basically here, like, who funds this pipeline? So OpenGL, I don't know, but I assume it's a big consortium. But VTK, it's Kitware, and I discussed with people from Kitware, like asking them, what is your business model? Because it's very strange, they support CMake, they support all of this validation, and like, where do they get their money from? And actually, they told me that 75% of the money comes from the US government. They get funds. Basically, they apply for academic grants. So I think it's just the way they do things in the US is that they put this kind of activity in a company. I assume that in Europe, it would be like a big academic lab doing this kind of work, but it's kind of semi-academic company. And then what's really interesting is that PyVista, actually the original developers, they are geologists. So that's why you have lots of geology examples in the gallery. And Vedo, that's the European Molecular Biology Laboratory. So basically, it's one of the team. I think they are in Barcelona.
Yes, the author of the library.
Yes, basically is a permanent engineer at the EMBL in Barcelona. So people basically who study morphogenesis, how does one cell differentiate into an embryo? So that's basically those two communities, they invested in this interface for VTK, and so everyone can benefit from it. And that's exactly what you want to benefit from. And
VTK have already kind of long history. So it's so OpenGL is early 90s, but VTK, I think it's 1993 or something like that. So PyVista and Vedo are more recent tools, but even if PyVista disappear, I do not think it will disappear because it has a big community of users. But you can, if you look at the more in detail in the PyVista code, it just calls some. So you have a Python VTK module, which is a way to call. It's okay. You have some here another layer of VTK in Python. So even if you do not have PyVista and Vedo, you can import VTK in Python. It will be not as Pythonic as using PyVista, but you can also use VTK. So they are based on solid tools, I think so. I think we can say that VTK will not disappear in the next 2 years.
A fun fact that I didn't know is that, the guys who created VTK, one of the founders is a guy who actually published the marching cubes algorithm. So, so whenever you have a volume and you want to turn it into a mesh, a binary volume, and you want to turn it into a mesh, the standard algorithm is called marching cubes. So basically, you compute the surface level sets of a function. So it's a standard algorithm like CGraph from the late 80s or early 90s. Basically, the guy created this company. So unfortunately, he died a few years ago. But that's a kind of solid ground to build stuff on. And PyVista and Vedo, the first commits were just 3 years ago, like in 2019, so that it exploded quickly. And I think that maybe a bit surprisingly, you have way more downloads for PyVista than for Vedo. And I assume that's because PyVista, it's data science friendly. So it's very easy to use, whereas Vedo, it's more for power users, probably.
Yeah, maybe PyVista emerged more as I don't know why one is more popular than the other. And yes, the fact that it presents things differently, and you have this logical separation between what is data structure and what is rendering. So for me, it seems more natural. I don't know if it's the case for everyone, but for sure. But with Vedo, you really are able to do crazy things with gates, etc., that you can't do. In PyVista, you have something, but basically you have one slider and two buttons, and you can't do really far in the interaction. But with Vedo, it's amazing what you can do.
If you want to impress your friends at CGraph, obviously you can do ray tracing and this kind of things.
Yes, but yes.
Okay, one question regarding building toy example or getting simpler data by extracting support from mesh.
Mhm.
So you show us that we could build a curve on the predicting mesh. That's one way to create a curve. What can you say about what can we do to either simplify data or create a toy example?
It depends. Simplification. So you can do decimation, but I do not know if it's the kind of simplification you want to.
That's one.
That's one answer. So I think you have access with Vedo to some mesh cutters.
Yeah, interactive and free.
So I think if I.
Because it's often a difficulty when you first start to try a new algorithm and you try with too big data, you waste a lot of time to set parameters, and it can help to extract smaller.
I can try to show you. Okay, it is supposed to work.
No,
No, you have to choose between
yes,
things.
yes. So basically, you
So maybe you
So-
add one or like
okay. Thank you.
maybe if you
Okay.
shoot underscore cutter.
It works. So okay. Yes, this tool. So yes, it is a tool that is provided by VTK. And so I don't know how you can save things, but I think it's possible. So I think, yes, with Vedo, all of what is possible is exposed into examples. So when you have an example of here, maybe it's the thing you want to do. You can, after, just copy and paste the code. So you go back after to PyVista, to source code. Okay. Okay. This is the code. So I think it's mainly calling widget from VTK, which is directly the box, and after you can so you can start with this code and adapt it to your case.
Can we have something close to like segment on the window, the part that we really cut?
Mesh cutter.
Où ça? This one. Okay. You want to challenge Vedo? Vedo can do everything. At the beginning, you try to challenge it, but after some time. So right click and move to draw line. Second right click for stop drawing. Okay. Hop. Z to cut. Working. Okay. Are you happy with that? I can save with S. S to save. Okay, I don't know. Maybe he saved it somewhere. Okay, so this is one option. And
so this is okay, and what you get, the structure, the data structure behind that is in the mesh. What that is coming as an object?
So here I don't know. You have to look at the code, but I think you can.
Ici un mesh edited.
Mesh edited. So I think I can. I can open it in ParaView. Okay. Okay, so yes, I can open it in ParaView and you can do after whatever you want with that. I do not know the code, so I can't tell much detail about what is the structure, but you can use it in ParaView. You can load it again on Python with PyVista. And
Yeah. Okay, and there is an application to navigate inside?
navigation. You really want to challenge Vedo. Navigate. Like you are. Yeah.
Yeah, if you zoom in and you...
Would you go into
Like creating some racing game with. I do not know.
So if you want to work with arrows, with distribution of arrows, the distribution of planes, of distribution, do you think that this is something it can be easily implemented in?
Yes, it's because you know, especially VTK, I think a big part of their money comes from physics simulation. So you always see
So the basic
that they do those
streamlines.
Streamline. They do it all the time.
Maybe something like that, not interpolate a vectorial field.
Okay.
You want to work with variables.
But you can do. You can also do like matplotlib.
No, but maybe you can show the one with simplet splines, you know, that tells you what is very easy to do, and then
This one?
no, if you go up a little bit, like interactive morphing. So fourth column and third row.
This one?
No, I was thinking about the one with the two curves.
Ah, this one, yes.
You see, that's exactly the kind of thing that we want to do, and so like basically all the graphical user interface is already taken care of.
Click to other instantaneously on the left
Yes.
panel.
Basically, you add landmarks yourself. So you click there, then there.
Okay, we'll put 3. And like this, and
then you type M, and I think it's going to show you the simplet splines. And obviously, this is not yet aware of variables. That's basically our job.
What's the difference?
It's just simplet splines. So I think if you explicitly
It's just a fine because there are only 3 points.
Yeah.
So it's less than.
So maybe if you add a few more points.
So it's not drag to do an LDM model with landmark pre-selection before.
Yes, exactly. It's really hard.
That's a state shape.
Yes, exactly. And basically, probably in a few rounds, I can show you libraries that exist for like volumetric implementation, like implementing LDM and volumes. It's very easy.
Nice.
Okay. Other questions? So yeah,
Thank
so
you.
thank you very much.
yeah,